are you doing a screen recording or is it a video recording?
The screen.
Okay.
The video is the least interesting part. Screen and audio. Okay. 5 o'clock? Okay, let's get going. So first of all, this was the results of the Post-it note feedback I got from you guys last week. I mean, it's been so long, I can't even keep track of who I'm talking to, etc. We have about 30 students, so this is not, none of these are particularly dramatic, but the homework too much. Yeah, there's quite a bit of homework, especially in the beginning, and I sort of warned you guys about this at the beginning of class, but there's just a lot of stuff we got to cover before we're able to talk about some of the more advanced topics. So, and I try to be cognizant of it, but I know it pushes a little bit hard. But hopefully it's interesting, and hopefully you also can tell the connection between the homework and the subject matter of the course. I'll keep on monitoring this. If I get a lot of exclamations, I might dial it back, but I really have a lot of stuff that I think they're first to get to, which is why I'm doing it that way. Notice that there were 5 people who thought it was okay, but 3, 7, and 5 is 12. It's still less than, a lot of people didn't have any comment about that. I was amazed that some people don't like the book. I love that book. But again, the numbers are so small, I'm not going to belabor it, really. The unclear site, hard to teach. This is not even in priority order, so I don't know what happened here. But anyway, the big one is this one. And I think that that's legitimate. It really was made worse by the fact of the changing around of the schedule because of the wind, the snow, and all that stuff. I don't really know how to make it better, other than to remind you that you need to look at the website for the day the day of class. So in other words, and this is of course a mess, but today is February 11th. So you would look at this page, and you would see this is the homework for today. And that's the only, and the way that is the official way, that's the official information. Nothing else really is important. For example, if you look at latte and it doesn't match this exactly, it's just because we haven't exactly coordinated them, and sometimes we're a little behind on that. If you find a date in latte that looks wrong, this is the date to believe. This is the right stuff. We just copy the information of these homeworks into latte. But unfortunately, there's not one chart with all the homeworks together. Maybe next year when I teach it, I'll update my software to do that. I do want to remind you of this link here, list of lectures, which has the list of lectures by date, including a summary of what the homework is. But it's just a summary. You still have to go to the actual page to see what it is. All right? But I'm aware of that. The other thing I want to change, there's changes that I want to do. I want to put dates next to these things, and I want to put a button on the top that says go to today to make it easy to find the right page. And maybe next year I'm going to have a page with all homeworks. But anyway, I acknowledge that. And all I can say is please be disciplined about looking at that page, because saying, oh, I didn't look at the page, that's why I don't have the homework, that's not so good. If a homework is difficult and you're running behind, you didn't quite finish it, talk to the TAs. They're very understanding. They'll help you get it done. If you feel like you're really behind and you're getting nervous, talk to the TAs, talk to me. We'll give you extra help. We'll give you extra time. I'm sort of setting the pace in the way the homeworks are written, but definitely open to input if there's a problem. If there's something confusing about the homeworks, like it doesn't really add up correctly, could easily be a clerical error, because I am doing, especially now with the snow, I'm doing a lot of scrambling. Yeah. So those are the ones that are important. Let's talk about this one actually, grading policies. So the grading policies should not be confusing. Let me just remind you of what they are. And maybe this is not what people meant, but all assignments other than portfolio review are graded 0 to 100. You get 40 if you don't do anything, don't hand anything in, you get 40. And it works its way up to 100 for like a really perfect job. Latte should reflect in the grading page the grades, the scores you've gotten. Sometimes we may be a little bit behind. We do our best to get everything graded for you within a week. And then if you look at this page on the website, down here, which is called grading, you see the weightings, so you can sort of see how things are weighted. So given those scores, some things are going to be weighted more heavily. Coding is going to be weighted more heavily than non-coding, and so on. So that's the general umbrella grading policies. The person might have been referring to, why did I get an 84 for this assignment and not a 95? And let me couple that with rubrics. We have a rubric when we score your work. So we decide, okay, this is what I'm going to be looking for. However, I don't believe in giving you that rubric ahead of time, because the rubric acts for me, or for us, like a set of signposts. Like, this is probably good work if I see this feature in it, this feature in it, this feature in it. If I see these three things mentioned in a paper, I would say it's a good paper. But I don't want a paper that only has those three things mentioned. So if I tell you these are the three things that are for us the signposts ahead of time, well, I think I'm sort of giving you the formula, and there's a danger that some people might decide to just be limited to that formula. So I'm not going to be giving you rubrics ahead of time. I'm going to give you verbal descriptions. I want to tell you about what a good program looks like. I'm going to tell you the kinds of things I want you to explore in the paper. I'm going to tell you all that stuff. But I'm not going to give you like a formula that says here's how you're going to reverse engineer, getting a good grade. Because I think for me that defeats the purpose. Any questions or comments about this? Anybody want to add to it or respond, react? Sounds reasonable? Okay, good. Go to the website, please, and you will see here self-assessment grid. Click on that. Let me just do something here first. Did I remember to put? Don't go yet. I forgot. I meant to put this. Don't go yet. Don't go yet. So I can correlate this later on when I do this again. Okay. So basically, the purpose of this close this again. The purpose of this, that you're going to all fill in, is the entries that correspond exactly to the learning objectives. And this is totally for me, not for you, so this is definitely this is not graded. This is for me to be able to have a sense of whether the students are, what the look of the class is vis-a-vis the topics that I'm trying to get across. Okay? So don't spend too much time thinking about it. These are topics that some of them will be totally unfamiliar to you, some of them will be somewhat familiar to you. That's just because by the end of the class, I would like to have everybody scoring these things high. And this gives me a way to monitor it. Go, 5 minutes or less. Look up to me when you're done so I can tell. And I can just move on. All right, looks like the majority of you are done. I want to point out, in case some of you didn't, hopefully you all noticed that this homework, the user service homework, was different from the one from Monday, which was the Sinatra demo or whatever it was called. They're two different things. Was that video that I made, was it legible? Was the sound okay? Was the pace okay? Who found it useful? Yeah, okay, good. So I'll do more of those. Okay, good. And I'm also taping this in case you want to go back. It's always interesting when you go through this room was supposed to have all the latest fancy stuff, but if you've looked at the recordings that Echo 360 is making, they're terrible. Sometimes the video is out, sometimes the audio is out. So I'm now doing it myself. It's a little bit less tech, but it works fine. Okay, so since we have 2 hours, I know not all of you can stay till 7. That's understood because I just pulled that time out of a hat. And those of you who can't will have the video to be able to look at. Okay, so it's not going to compromise you too much not being here. It's just stuff that I basically would have skipped if we didn't have the time. So I'm going to try to go at the regular pace, even though I have a lot of stuff that I'm going to cover in a way what I was going to cover on Monday and on Wednesday. So let's go to the very beginning. Now you've been doing this in your homework. In a way, you've been exercising these ideas, and now I'm going to try to give you the conceptual background behind them. Okay? So when we talk about a client and a server in the world of the web, what do we mean? Well, basically, they're both computers. This laptop can be a client, it can be a server. In fact, when you're testing your Sinatra, your laptop is acting as both a client and a server. So what does it really mean then? Well, first of all, it's kind of an outdated concept because of what I just said. But in a way, it is the server is providing a general service to a number of people out there, and the people out there are called clients. And the most standard case, obviously, is a web server, which is like yahoo.com, and a web client like Safari. Okay, so that's a web server and a web client. Now, when I say server and client versus web server and client, I'm now going a level more specific. By the way, for some of you this is old hat, for some of you it's new, so those of you for whom it's old hat, you can have fun catching me saying something incorrect, or catching me leaving out an important detail, and call me on it. Because I might say something incorrect, or maybe I might say something incorrect on purpose, to see if you're listening. Okay, so we draw it like this. This is a canonical server. Oh, this is not very clear, is it? No, always. And this is the canonical client. Okay, wait. I want one that's really dark. That's better. Oh my God. No, it says erase. It says wet erase. That's not good, is it? Wait, forgive me while I solve this problem. Anybody have a Kleenex or something like that I can borrow real quick? Nobody? I hate the room, this fantastic new glass. Nobody? Any trash in here I can use? Nope. All right.
Can you use another marker?
I could do that.
Okay, there's a bathroom right outside.
Oh, yeah, that's a good idea. Can you get me something? Thank you very much.
I think I got one.
Ah.
Oh,
Oh, what's this? No, I got. Okay, you got a pen that works, but I'm still trying to erase the damage I did to this board. That's pretty good. So this is not anywhere near this board. Okay. No, seriously. I mean, this is a beautiful new board. A client. So we have a server, and we have a client. Okay. Whatever. And they talk to each other over the network. But as we know, the network is global, right? So there's no wire connecting one to the other. Thank you. There's no wire connecting one to the other. It actually goes through the whole internet. It goes through the whole internet. So in fact, it can travel all over the place. It's not just a straight line. It can go book, 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 eventually here. Characteristic of a server on the internet is it's got an address, like a phone number. If I'm going to call somebody, I need to know their phone number. The equivalent on the internet is an IP address. Everybody's heard about that? An IP address, which looks something like 42.91.0.171. And it's true that every node, everything in the internet has an IP address. So in this room right now, there's probably 60 to 80 different IP addresses. because most of you have at least one mobile device, maybe two. You have a laptop. I have one. There's computers here. Everything has an IP address. And so the way a client talks to a server is by sending a message over the internet targeting a certain IP address. Now, because nobody wants to memorize all these numbers, you're never actually typing in these numbers. You're typing in names, like brandeis.edu. Okay, which gets translated by the internet. What part of the internet does the translation? And what does it stand for?
Domain name server, so DNS.
DNS, domain name service, which is a service on the internet which says, here's a name, give me the IP address. Okay, so the browser knows.
It's actually system.
Yes.
Huh?
Neither of us. It's actually system.
Okay, good, excellent. So domain name system. Really? Okay. Anyway,
Wikipedia says.
pardon?
I was
That's
very
what Wikipedia
surprised.
says.
Wikipedia is always right.
Wikipedia is always right.
Yes. So anyway, so basically, you type in the URL into your browser. Among there is brandeis.edu. Your browser actually talks indirectly to the domain name service system, and it gets an IP address back. And with that, it can send a message over to the to the server. Now, what is a message in this context, right? Well, a message is bits or numbers. So like that. That's like a message. It's just bits. And when these bits arrive at the other end, how does he know how to interpret those bits? How does he know what they mean? Like, I just wrote a bunch of numbers there. What do they mean? I'm telling you there's a specific message in here that's saying something very specific. But you can't tell what it is, right? Why can't you tell what it is? What don't you know? What don't you know? Only one answer per person, please. What don't you know? 617-646-254-0122-1349-1100000. You don't know the protocol, right? So the protocol, when you hear the word protocol, what that means is simply an agreement among computers or among people about how to interpret a set of bits. Protocol can also be thought of as a format. It can be thought of as a syntax. It's an agreement to interpret these numbers, because really what goes over the wire is just numbers. Bits, numbers, okay? So in this case, I happen to know that the messages in the PILO protocol is that the first 3 digits are an area code, the next 7 digits are a phone number, the next 7 digits are a social security number, and the last 3 digits are a deposit into my account. So now that you know my protocol, you can understand this message. That's why the idea of protocols comes into play on the web. Okay? Because there's actually hundreds of protocols, hundreds of standards. And there's an organization, in the case of the web, called W3C, the World Wide Web Consortium, that is the ones that, exactly like a legal body, describe exactly what these protocols are and what they mean. And without that, none of this stuff would work. So DNS is a protocol as well. There's a specific way that this client, my laptop, can ask the domain name service, what does brandeis.edu mean, and in a specific way it can answer. That's protocol. Now, let's think a bit about another cut at this. When I type in brandeis.edu, http:// schedule, and into my browser, and I get back a nice report with the semester schedule. How did that work? At a high level, what happened? I'm going to stop at a row and hope that somebody from that row answers. what happens? Nobody? You must know. I know you know.
So, what was the question? Sorry.
Ah, that's the problem, yes. It makes it hard to answer. Anybody else have an answer? No? No? Let me try this one. Yes, thank you. I knew you knew.
So, in this case, okay, so first we go to your browser goes to the domain name system.
Yes?
Finds
Yeah.
out what the IP address of brandeis.edu is.
Yes. Correct? Go on.
So,
You can say, uncle, and then I'll pass it to somebody else.
okay, I still sort of remember right
Okay.
now. We'll see how far I get.
Yeah.
And then as part of the message it sends to that
Yeah.
server is the /schedule.
Yeah.
And
We
that's
call
how
the path.
Yeah, and that's how the server knows which page to return to it.
Yeah.
In this case, if the schedule is your personalized schedule, then it becomes more complex. But
Yes,
if it's
that's
just the same thing for everyone, then
Yeah.
it's just a GET request.
Yeah, it's a semester schedule, like when the holidays are, that thing.
Yeah, then that's just some static HTML page that the server returns.
So the server returns, in response to this message, a bunch of text, which is an HTML page. And really, in the final analysis, that's all a web server does. A web server receives a request, which is identifiable at the first level of detail by the path, and its job in life is to return back to you a page which is HTML, which the browser can display. Remember that. It's fundamental. It's true no matter what language you're working in. It's true as long as there's a web. But it's, of course, incomplete. What about this bit? Who can do some riffing on what this is saying? Yes. I hear you.
Hypertext transfer protocol.
Yeah, that's correct. What does it mean, though?
It's how
I don't think anybody can hear you. I have to stand over here.
hypertext transfer protocol.
Yeah.
Most of people using it with TCP.
Yeah.
It's how the page is transmitted.
Mm-hmm.
So it's
Yeah.
a protocol for like.
It's a protocol, first of all. That's a very important one. So yeah, you're basically on. Anybody want to add or object? Okay. So yeah, basically this here tells the browser what language to put the request in, so that the server will understand it. Okay. And it also tells the server what kind of answer will be understood by the client. So it establishes a language. It's like, I know how to speak Dutch and English. You know how to speak, what language do you speak? Chinese and English. So I meet you and I say, you speak Dutch? Praat je Nederlands? You go, good. You go to me, ask me if I speak Chinese in Chinese. Ask me if I speak Chinese in Chinese.
你说中文吗？
Then I go, do you speak English? I go, I speak English. Let's speak English. Okay? That's called a protocol negotiation. All right? So that's what you need to figure out if these two guys can talk. Because this guy can maybe speak a lot of different protocols. This guy can speak a lot of different protocols. And they have to figure out what protocol they both talk. Okay? So once we know that it's HTTP, now we can talk between these two. So let's tear this thing apart a little bit more. So HTTP is a protocol. As I said, you can think of these magic numbers. It's just a way to interpret these numbers. So what are the numbers that are being sent back and forth? Well, it's a request and a response. That's the other thing you always have with the web. This guy's making a request, and it's getting an answer, which is called a response. Okay? Now, the fact that it's request response is not a universal thing. It's the fact it relates to the fact that we're using HTTP here. And by the way, if this sounds like a lot of boring details, you're going to have to write code that does all this stuff. So if you don't get this, you're going to have a hard time doing the rest. So it's really fundamental. Although I'm building, the foundation up in blocks. So It may be a little tortured. Okay, so we have a request and response, right? So let's take a look at the request. So as I said, these are some of the parts of the URL. So the first thing the browser does is it parses this and says, okay, I know that I use HTTP, good. Okay, I know the guy I'm talking to is going to be brand.edu, good. So we know who we're talking to. And finally, this is a big part of the message. So, and we're talking HTTP. So an HTTP request has a ton of information in it, but I'm going to give you the most important parts. HTTP request. First thing is the path. So in this case, it's /schedule. Second thing is the desired data type of the response. What I'm going to take back. In this case, it's going to be text -HTML. Who's heard the word MIME types? Yes? MIME types? Okay, you may not many of you have. There's a collection of, you can Google that, collection of types that are represented in textual form like this, a word, dash, another word, which are all the vocabulary of possible data types. Okay? So, it says I can receive text.html. This is my URL, this is my path. And in addition, there may be one or more parameters. Are they called parameters or are they called arguments? I forget. That's called parameters. Yeah. And finally, and most importantly, is the verb. Get, or put, or post, or a few more. So these are the most common. So you have the verb, you have the path, you have the allowed response, and you have the parameters. In this case, because you're typing it into the browser, into the address bar of the browser, I guarantee you what you're doing is a get. So the browser is going to initiate an HTTP request to the server. He knows who it is, and the verb is going to be get. The path we know, /schedule. The response, because the question is coming from a browser, is text-HTML. And finally, the parameters, in this case, there are none. But for example, you sure have seen question mark name equals PETA. Name would be a parameter. So for example, name equals so. Okay? The job of the server, when it receives an HTTP request of this form, is one and one thing only, which is to send back a bunch of text, which is HTML. That's all a web server does. Let me show you a little demo. If I can find my crib sheet.
Do you have a question?
Absolutely. I love questions.
So when the server sends back the HTML,
Yep.
does it send it in the form of this language that the protocol knows how to translate?
Yeah, it's text. I mean, in that case, it happens to be text. And then another level of syntax is that the text is a legal HTML. It's a valid HTML string. Because remember, text is just numbers too, obviously, right? So, yes?
Does the client know what type of thing it's going to get back? Does it,
Yeah.
I mean, in this case, does it know it's going to be an HTML? Or
Well, it asks for HTML. It said, all I'm going to accept back is HTML. Okay? But it doesn't know beyond that. Okay, it just knows that it's HTML. Any other questions? All right. Let me do a little demo. You guys know that there's a find box up here? Okay. Here we go. Okay. I always need this to run. Yes? Was that it? Mumble? Okay. So Telnet is a program that is available on any kind of Unix or even on Windows probably system, which lets you manually generate requests as if you were a browser or as if you were something else. You can literally just fake it out. Okay? So I'm going to type over here, and you can do this playing along at home. Okay? I'm going to type here telnet. I'm going to point it to a domain name called example.com. I'm going to hit enter. This is a typo. Sorry. and it's now thinking, and it's not working because I forgot the port number. Telnetexample.com 80. Okay. Okay, so it's good to go now. So it's now it says, okay, I found example.com and I've told him there's an HTTP command coming. What do you want it to be? That's where we're at right now. So the HTTP command we want it to be is going to be get / and this, the fact that I'm writing it this way is part of the protocol. This is exactly the required format. So it's very strict. Okay? Get is the verb, / is the path, HTTP 1.1 is the protocol version number. I hit enter. Now I have to say host, oops, this is a parameter that's required. Okay? And I'm going to hit enter. And this is what the server answered when I said that. Now, if you know HTML, you see that this is HTML. The server answered me with HTML. Okay, so I'm not using a browser here. I just use a command line utility to ask the server an HTTP request, and it answered me as HTML. So if I take this text, just to prove my point, because I like to do that, and I get it onto my clipboard, up to here, copy, and I go to my text editor, and I create a new file, and I put this in it. That's just the same text I got directly from the server, and I save it to my desktop as demo.html, and oops, sorry. Here it is. There's that file, and I double click it. I get what the browser would have displayed. So you see what I did? I got it right off the utility. I pasted it into a file, and if you look at my URL up there, it's just a file on my computer. Okay? Let's do another example. I'm going to purposely put a mistake in there.
Your file looks the tiniest bit different from the actual example.com.
It does?
Yeah.
How so?
Their example domain sort of main part. Maybe it's on my screen. That's weird. On mine, the main part is white, then outside of it's a little bit.
Are you in
white.
Safari or Chrome or something?
Chrome.
Maybe that's why.
Yeah, maybe why.
Okay. Thought you had me there, eh? Okay, now I'm going to do something a little bit different. I'm going to go back to my crib sheet, and I'm going to type get / HTTP / 1.1. I'm not going to put the host example.com, and I get some HTML back. Let's see what it says. Well, I can read it, and we can see here bad request. So this server has decided that it will not allow me to make a request to it unless I indicate in my HTTP request as a parameter what the name of the host is that I want to go after. I won't get into why that's required. It has to do with security and preventing certain kinds of attacks. But this server just decided that if the one sending me this GET request doesn't even know what I'm called, I'm not going to play ball. Okay? Let's just play some more. You can go to other sites, see what happens. Let's go to brandeis.edu. And I'm not going to say get / what's up HTTP space / 1.1 host name brandeis.edu. Oops, no capital. So I'm creating a manual GET request to brandeis.edu to find out what's at that location. And it says, bad request. That's more than just the fact that I put a path that's not valid, because I betcha, although I'm not sure, if I go get / slash http colon, no, slash 1.1 post colon brandeis.edu, you get the same error. Okay. One more thing I forgot to mention. So this is what it asks for. The response also has a pretty elaborate structure. It's not just the text HTML. The response also has a bunch of parameters potentially. And then in addition, very importantly, a status code. Okay, and when you see error 404 that you've all seen, that's an HTTP status code. In fact, if you look, you go to a funny website, I think, which is called HTTP status codes. Is that what it's called? Yeah. Good enough. So here are all the status codes that HTTP can return, and here's all the 400s. And if we look at all the 400s, there's 404. Oh, there it is, 404. So the 404 you see in your browser is actually just one of the HTTP protocol's formulations of what are legal status codes. And one of the important ones are, that's not here, which the one we just saw, which is redirect. Who knows what that is in their head? Is it 200? No. Yeah. So you can return a 307 or a 301 to indicate the page you're looking for. It's like, these are not the droids you're looking for. Anybody know that reference? Nobody knows that reference. Thank you.
So, well, no, this is relevant, which is combining Telnet and Star Wars.
Yeah.
You can watch it through Telnet in
Ah.
ASCII artwork.
Sweet. What? Can you give me the URL?
Yeah. It is, you do Telnet towel dot, and then it's BLINKEN lights dot NL.
N is in Norman?
Yep.
Oh, that's Holland, you know.
This goes on forever.
I know, but we can control C it.
Star Wars, yeah, it's a long
What else?
movie. That's it.
Oh, that's funny.
And then it'll just, if you just wait a few seconds, it'll keep going.
Okay.
And
So interesting. So this is interesting because, hey, there's no control C, but I always have this.
Star Wars goes on forever. You can't
I have some questions. What protocols did you use? What does Telnet do by default? Because it did a Telnet request, and I didn't give it the protocol or anything, so it's taking all the defaults. I won't get into it. But anyway, that's cool. So, but anyway, HTTP, the main point is HTTP has these status codes. And if you think about the homework you did, you know that you were talking status codes, and you're talking gets, and you're talking all these things in the code for Sinatra, and now I've sort of showed you here where that comes from. Okay. Okay. Now, so I talked about HTTP in detail. So the protocols have the key things is a get, put, post, and each one has a slightly different meaning. I won't bother with that right now. And it returns one of some format. And we've now talked about the three building blocks of the World Wide Web: HTML, HTTP, and the syntax of the URL. Those three things are the foundational things that were invented by Tim Berners-Lee back in 1980, 90 or something like that, whenever it was. URL, HTTP, and HTML. Okay? That's this whole section here. Any questions about that? So mapping this to the Sinatra homework. So when you write the service.rb or whatever the file's called, the main program in Sinatra, what you're basically telling it is, given this HTTP request, what should you do? That's really at the most fundamental level. If you do get /user/3, what you should do is return this text. Now, of course, the text that you return is not a text file. We use something called, we'll get to this in a minute. Actually, this is probably a good time to get into something related to that. Given the real web servers actually don't just return static text files. They return web pages that have content on them. Observe that, for example, if I say, if I go to a website and I say, slash user slash name question mark, sorry, more likely it's slash user question mark name equals pedo, and it displays a profile for pedo, right? And it has my name on it, all my other information. What is going on here is that you have a database somewhere which has all the people in it, all the names of all the members and the profile data, and you have a collection of page templates or views which are essentially HTML with a lot of holes. HTML with spaces left open where you're going to stick data. And so one way to think about the job of the web server, once you go beyond static pages, is data plus template is what's returned, HTML to browser. Okay? So a key part of what the web server is doing is looking up the data in the database, whatever the data is, finding the appropriate template or view file, marrying together, and sending them back. All right? So that's why the database obviously is very important. Another part that's very important in this example, for example, is that, and you saw this in your Sinatra code, it might say get slash user, and then in the code somewhere you will see params name. Does that look familiar? Can anybody explain in the context of what I just said what that might mean? Or take a stab at explaining it? Yeah.
So the name is the parameter that the user put in the text box, and so you want to retrieve. When you get a request, you want to get one from the database by that name.
Mm-hmm.
So basically, the Sinatra translates that into a SQL query, which retrieves it from the actual database that resides in the backend.
No, I think you overshot. You overshot the target.
Too deep. Okay.
Yeah, not only too deep, but it doesn't do all that. Basically, so anybody else want to take a stab at this? Because you all wrote some code that looked like this. Anybody? I mean, it's okay if you don't, but if you want to take a guess, an educated guess, yes.
Is this missing part of the get URL? Shouldn't have like a slash colon name afterwards?
No. Good. Very, very good point. I could have written it like this too. Get user colon name. Wait a minute. Is it? There's params. What's the other one called? Params and huh? Huh? Arguments. Which is which? Okay. There's two. I have to. Well, let me show you. Instead of floundering around here. See if I have anything in here that looks like. Oh, I know, the book. I can find it in the book. I just have to remind myself which is which. Help me find it if you see it. Okay, then I have it. Let's see here. Service. There it is. No, that's not it. Let's see. I don't think that's it. No, but it'll. No, that's Rails. I don't want that. Okay, I know the other place I'll look. Go away. Sinatra. Okay. It's a simple one, a simple one. Params, right? And the other one is called bear with me. Ah, is that what it is? Let's see. No, nope, that's not it. That's not it. Oh, maybe they get combined. Oh, I take it back. They get combined. Title and author, they're both params. Okay, they get combined. So there's, from the point of view of the URL, there's two ways to get information to the server in terms of the address. I could have written it like this, or I could have written it like this. Okay? As far as the protocol is concerned, this is a path with no HTTP parameters. This is a path that's only /user with one name parameter called name with the argument with the value pedo. Sinatra combines those two. Okay, so let me go back to this map. So in both cases, it would be here. So what's going on is this: Sinatra receives the HTTP requests, analyzes the path, locates any parameters. Given the path, it now goes to find one of these bits of code that corresponds to that path, get/user. And then, if it matches, it executes this code. That's it. At the end, it will have a bunch of HTML to send back to the server. So what is in this code? Well, this code wants to get additional information that was part of the request. So Sinatra very nicely parses that out and sticks it into a hash. So the name here gets put into params as name like that. So you can pull that information out of the URL. So it's sort of setting up the context for you to do now what Eden said, which is to take that params. Now we know the user's name. Now we can go and ask the database, do we have a record with that user's name? So a Sinatra program, in its most simple, is a bunch of little code blocks that say how to handle each path. And it just goes from the top to the bottom until it finds a path that matches the one that it's working on. And the code that runs then, its final job is to generate a bunch of HTML. Okay? All right. Good. Questions? Does this connect with what you guys did homework-wise? Yeah? Anybody still bamboozled by something or puzzled by something? You want to throw a question at me? Because I'm sure you're not the only one. Often one person has a question, but they're not saying it because they think that they're the only one that has a question, but really half the class has the same question. So try me. Yes?
Are you allowed to have different, like, you know how this get put?
Yeah.
Like, are you allowed to have different ones for the same path?
Yes. A get and a put, yes, they're different. Yeah, exactly. So for example, I could say get user pedo, but I could also say delete user pedo, which would have a different effect, obviously, with delete. But the mapping of this HTTP request to a piece of code has no semantics. What I mean by that is, it's up to you, the programmer, that decides that the code behind delete del posts actually does a delete. The verbs are just conventions. Nobody, except the one who writes these lines of code here, knows whether it's actually going to delete a record or not. Sinatra doesn't know anything about the database. The database is brought in by the code you write. Sinatra's job in the world is pretty simple. It's to interpret the URL, interpret the HTTP, find the appropriate bit of code of yours to run it, which will produce some HTML, and send it back. That's basically what it does. That's why it's so lightweight. That's why it's so much simpler than Rails. If you know Rails, this is like a baby version of Rails. Okay? Anybody else have a question, please? Yes?
this is a less specific question, but why are we using Sinatra instead of Rails?
Ah, that's a great question. Can it be because I wanted to learn Sinatra? Yes. No, but also because Rails is a big thing to learn. And for our purposes here, we can get everything we need to from Sinatra. But I also thought it would be good for your personal toolboxes and for your resumes to show you know a whole other platform. And truly, I wanted to learn it myself. But it's well known. I mean, I've always known it was there. And the people, I mean, when we get through this course, we can have discussions about when you would use one, you would use another. But for now, that's why. Anybody else have a question? Yes? You see, you guys notice how excited I am when somebody asks a question?
I'm confused about exactly what Sinatra
Is. Okay, great. Great question. So first of all, Sinatra is a library of code. It has nothing more. It's a bunch of Ruby code. In fact, I haven't looked at it, but people say it's actually not that much Ruby code. And so it's a bunch of classes and objects and methods. And when you say Ruby, for example, service.rb, so it's running a Ruby program, and it waits a moment, then it comes up and it says listening on port 3000. Literally, a program was run, and because the first line of your program is something like Ruby, well, actually this is so defaulted you don't see it, but essentially when the first thing it does, a program written with that library, is it tells the network connection that your computer has, it tells it, please listen to see if anybody is sending me a request, because I want to handle it, and then it waits. And it waits. And then eventually somebody, like a browser, sends it a message, and it wakes up, and it runs this code. Yeah?
So you mentioned running on port 3000?
Yes.
The port flag?
Yeah.
But when I tried running on port 3000 with the port flag, it just still ran on the default port, like 4567.
Wasn't that because of the hyphens in? But that may be the same problem you had. Which is to say, it didn't recognize that dash as a dash. It was using it because you copied it out of a PDF, and it was using an M dash, which typographically is better, but it's a different ASCII code. You got to read the forum, man.
There's a lot of emails there.
Ah, so sorry. I saw another question over here. Yes.
Yeah, so just if I got it straight, get is nothing but a method that was written for Sinatra that returns true or false?
No. Well, there's a few things. Over here, get indeed is a method in Sinatra that takes two parameters, a string, which is to be the URL, the path, and a block, which is code to run. And if I can just imagine what the code looks like behind the scenes, this is creating an object in a table of objects of all the paths that can be done. And there's a top-level driver that when it receives a request, it asks this one, do you know this path? And when he says yes, he says, okay, run that code. And that's basically what it works. So it doesn't really know. So you could make everything a get. You'd be writing kind of like incorrect or inappropriate code, but there's nothing technical that would prevent you from doing that. More questions? I won't stop until I get at least one more question. Come on. Nada? Nothing? Nothing. Okay. Who is there anybody who did not succeed on the Monday homework, just out of curiosity? Yes? For lack of trying or for lack of not succeeding?
I mean, I just couldn't get everything set up.
Okay.
Always
Did you spend hours and hours and hours on it? It was just dead in the water? You know that we have help and get the help, because it is important to do that one and the Wednesday one. Anybody else can tell me why you got stuck?
Yeah, well, I was explaining to you with Nick, just like I was messing, because I was trying to fix it.
Yeah.
But I guess one of the ideas someone posted on Stack Overflow messed up
Right.
the file.
Right. So that happens. So we're building, even though we're, it's just a college course and it's only one semester, we're building software on top of a very, very complex system with a lot of moving parts. It's like a jet airplane. And so you can mess it up pretty easily. You can install a gem of the wrong version. You can run a Ruby version that has a bug, because Ruby comes up with a new release constantly. Yes, 1.9 is fine, but there's 1.9 patch this number, which maybe had a bug. There's a lot of ways to make it just enough that it doesn't work. And so, yes, it's too bad, but not, this is on purpose, it's too bad that the thing doesn't just work. But an important part of being a software engineer is learning how to troubleshoot and learning how to deal with the frustration and learning how to get help when you need it instead of beating your head against the wall. And so, yes, it is not necessarily pleasant, but it is kind of the life of the software engineer. That is what we do, is troubleshoot and debug and test and getting things to work. Once you get the grandiose vision, you know, the 3 protocols, that's beautiful, that changes the world, and then you still have 99% of the work to do, which is to get a system to actually work. Any other questions? Okay. Right. Let's go on then. Now for something completely different. We're going to talk about databases and data modeling. So, everybody ready for that? It's totally different, something else. Okay. So, in our world of database-backed web applications, that means that there's a repository of data, of records, that are stored on the disk somewhere. And it's always the case for good object design reasons that your server has a separate thing called a database. And I'm talking about code here. This is Sinatra, let's say, and this is the database. And in fact, the database then stores stuff on the disk. We call this persistent storage. What is your persistent storage strategy? What is your persistent strategy? How do you persist that data? That's how that word is used. And what it means is, where do you put it so that when I turn my computer off and turn it back on again tomorrow, it's still there? The database system is a separate entity, and there's many different kinds of databases, okay? The one that we use the most often nowadays is called a relational database. This was a model for storing data on disk that was invented in the 70s or something like that. And basically the characteristic is that the data is stored in rectangular tables, okay? So in addition to relational databases, we also have NoSQL databases, which you might have heard of. NoSQL databases. NoSQL databases are a whole different category of databases. They're kind of new, and they don't use SQL. SQL are the 3 letters. SQL stands for, what does it stand for?
Structured query language.
Structured query language, okay? And it was invented like in the 70s or 80s. 60s or 70s. Okay? NoSQL doesn't use that. So we're going to focus on SQL, and then I'm going to contrast it with NoSQL in a second. But the crux to understand is that the database's job is simply to make your data stick around. And depending on the characteristics of the data, the database might be better or less well suited for storing that data on disk. So what is the characteristic of a relational database? Well, let's take an example and think about it. Let's say I'm making a system to keep track of courses and students, right? So think about that for a second. I want to have a course, Cosi 105, has a name, obviously. Maybe it has a time slot, 6 p.m., no, 5 p.m. It has a classroom, whatever. And then I have then I have students, which have a name, Tito, address, Arlington, a major, Cosi, etc., right? So the first thing you have to think about when you start thinking about your database and designing your database is what are the entities, what are the things that you want to store in the database. And in this small example I've given you, the entities that I'm trying to store are courses and students, right? So the chore of data modeling is a design process, and the design process is, given that my application needs to do certain things, how do I break down the information and fit it into a database? That's the data modeling exercise. And what you need to know about a relational database is universally true, and there's many different brands, as I said, relational databases, is a few key characteristics. The data is stored in tabular form, only and exactly in tabular form. A database, let's say called, let's call it latte, has a number of tables. Let's call this one students, and call this one courses. So the database has many tables. Tables are just rectangular spaces. Each table, I hate this pen, you can barely see this, but can't do any better. Okay, I'll try this one. So that's two things, tables and the database. This is sometimes called, so this is called a table. It may also be called a relation. And then the table always has a series of columns, like name, address, and so on. So these are called columns, sometimes called attributes. That's the third characteristic of a relational database. So tables, the database. Each of these things, these are all called records. Can also be called rows. That's another characteristic. Each one has a unique identifier known as the unique key or the unique ID or the key. So generally they're numbers. And the characteristic of that is it doesn't change. Once I create a record for Peter, if it's ID number 712, that's it forever. And then finally, and maybe most importantly, is that there can be relationships between the tables. And the action of data modeling or database design is the action of taking your problem domain or your domain and understanding how it gets mapped into a set of tables. So far, so good? So what are the questions you have to answer? You have to have it here. First question is, what are the entities? Okay? What are the entities? In this case, we have students and courses. Second question you have to answer is, what are the properties or attributes of each entity? And if you're trying to design a system that, for example, runs Twitter, your entities, well, you have to figure out what your entities are and what the properties are of each entity. Then you have to ask, is something contained inside of something else? You know? Actually, let me skip that one and keep on going. Because I think more important than that is to think about the relationship. To think about how many x's are there for a y. And the choices are, well, where this is going is it's going to be either one-to-one, one-to-many, or many-to-many. So for example, what is the relation between courses and students? Somebody who's been listening, yes?
Well,
go ahead.
Many to many.
Because, go on.
Because there are many students that have many courses for each person.
Close, but you can be more precise. So anybody, you got it, but I want to be a little bit more precise. Who wants to be a little more precise? Yes?
Many students take many courses.
Well, all right, yes, go ahead. You want another cut? Yeah, go ahead.
So each row has multiple rows that it connects to or has a relationship with?
Yeah, but, yeah. Pardon? Back, did you have your hand up?
Yeah, like I was going to say this.
One student has many courses, and one course can have many students. So it's a many-to-many relationship. Okay, so you were right. I was just playing around to get a little bit, to get it, the real sharp statement of it. Okay, so let's pretend in this weird school that we're in, that students can only take one course. I can just take one course. So now I'm saying the relationship between students and courses is one course has many students, however, one student is only one course. Okay? So that's the simplest case, one to many. And there's a million cases like that. You know, if you want to make an owner and a bank account, or a father and a child. I mean, it's just very, very common, one to many. So how would you represent that in code? In code, you would put a pointer, right? You would say, oh yeah, I just put a pointer in here, or an array with all the students that belong to this course. You don't have that in relational databases. There are no arrays, there are no pointers. There's something else that does the job of that. And that something else is the notion of a foreign key. And I'll explain very quickly before you get totally whacked out that expression. What if I put, these are the students, right? These are the students. And remember, a student can only take one course, but a course can be taken by many students. So what if I added a column here that was a course ID for the student? So student 1, Peter, is taking course 4. Student 2, Nick, is taking course 5. Student 3, Ayad, is also taking course 4. So we have here 4, 5, 5, 4, 4, whatever. We know that the numbers that appear here all must be indexes of this table. So there better be a 4 here and a 5. And in fact, if I want to know everybody who's taking course 5, all I have to do is look in here for all the 5s. And this is another way to represent a pointer, you might say, but it is the essence of the way in a relational database we create relationships. So play with that in your mind a little bit. Think about an example where I want to represent seats in a classroom. I have a seat record, it's a chair record, and the chair record has the position in the room and whether it's occupied or not. The classroom has a list of chairs, right? It's crazy because I'm just looking at chairs here. So we have chairs. Chair number, ID number 1 is at coordinated x comma y, and it's occupied. Chair number 2 is at x prime comma y prime, and it's occupied. Chair number 3, it's not occupied. Okay? And then over here, I have so these are the chairs, because we're very particular about our inventory of chairs. We want to know where they are at all times. And these are classrooms. And classroom 1 is called, this is called Gzang 124. And then we have other classrooms here. So I want to record in my database that a particular chair belongs to a particular classroom. How do I do that? What do I have to add into this design to represent that? What column do I have to add where to represent that? Say what? Yes?
You need a class column in the chair table.
I need a class column in the chair table. Because this chair number 1 is in classroom 1. This chair number 2 is in classroom 2. This chair number 3 is in classroom 1. Okay? So I add a column to this, and the column represents the classroom where this chair lives. What about if I have a town, towns, and houses? House number 1 is at Intervales Road, and it's gray. House number 2 is at Main Street, and it's white. House number 3, etc., etc. So this is the street, and this is color, because I'm a painter and I'm keeping track of all the houses I paint. And over here I have the towns. I have town number 1 is Waltham. Town number 2 is Arlington. And I want to represent the fact that a certain house is in Waltham or Arlington. How do I change my model to represent that? Anybody around here who wants to take a stab? Can you see the board okay? Yep. Yes.
House.
And what good would that?
You you'd be able to find out what town the Chinese house is.
So I would add a town column to the house. How do I know I didn't add a house column to the town? Which is always a very easy thing to get confused about.
Because one town can have many houses.
Right.
One house can only have one town.
One house can only be in one house. One house can only be in one town, and therefore the town ID goes into the house record. Okay? Now, let me make life more difficult. And I will not expect you to figure this out unless you're really clever or have done this before. But let's go to the real example of classes and students. So we have courses, and we have the name, Cosi 105, classroom X, whatever, and so on. And we have students over here. Let's get rid of this. Students. And student 1 is Tito, student 2 is Nick, student 3 is Iyad, student 4 is Tim, etc. Okay, but now I have course number 2, Cosi 166. Now I want to represent the fact that one person can take more than one course, and of course one course can have more than one person in it. That's a challenge. This is a many-to-many relationship. Yes?
So how would you represent it?
How would you represent it? But do you have the answer in your head? Boom. You explain it carefully so people understand. Go.
So basically they have, because this is a many-to-many relationship, each entity, each tuple in the left table can have some relationship with any other tuple in the other table. And so it can be joined with a tuple in the other table. And that joined relationship can be represented by a third auxiliary table, for which basically encapsulates a relationship between a key representing a student from the right table and a key representing the course for which that student is taking in the left table. And when we join that relationship table on either course or student, we can from that decipher what is the course number and what is the student name of the student that is taking the course. So that third table is basically a relationship table that we could call taking, which represents what student is taking what course. And we don't need that first column.
But every record has a key. Every record in a relational database has a unique key.
Not in a joint table.
Every record in a relational table has a key. Primary key. You always have a primary key.
In here it's a composite primary key which composes
Okay,
of.
we don't have to argue.
Okay. Sorry.
Every table in a relational database has a primary key.
Okay.
Okay? So let's take, that's correct, totally correct. Let's take this apart a little bit. Okay, so we have student 1 taking course 4. Student 1 is also taking course 3. Sorry, student 1 is taking course, I got this backwards. Let me just change this around. 1, 2, student 1, 1, 2, 3 is taking course 1, 2, 1, 1. Again, student 1, me, is taking course 1, Cosi 105. Student 1, me, is taking course 2, Cosi 166. Student 2, Nick, is taking Cosi 105. And student 3, Iyad, is also taking Cosi 105. All right? Very simple once you get the trick. And the trick is, the shortcut is, whenever you need a many-to-many relationship, and you will need them often, because they're all over the place, immediately think, I have to add an additional table to indicate the relationship. It's just a rule, more than a rule of thumb, it's a rule. But if you approach it very conceptually, theoretically, you might wrestle with it. So just immediately, I gotta make another table, let's see what I put in it. Okay, everybody follow that? So, so the effect of all this is that, for example, if I want to know everybody who's taking Cosi 105, what do I do? Talk me through it. I want to see a list of people taking Cosi 105. Talk me through it. Who wants to do it? Yes?
Would you go to the third table and look for 105 in the second column?
Which table?
The third one, the relationship table.
This one here? What would I look for here?
105.
But there's only ones and twos here. There's no 105 here.
Oh.
Keep on going.
So what do the ones and twos represent? I think I misunderstood.
That's good. I'm sure you're not the only one. So these things are what I called before foreign keys. And the word foreign key is just jargon for the fact that this number 1 corresponds to a key, because this is the key of this table, of another table. So this number 1 corresponds to the first record number 1 in the student table, and this key, this number 1, corresponds to the course with the key 1 here. So these numbers are picked directly from the key of the table corresponding to whatever that particular column is for. So this column might be called student underscore ID, for example. This column might be called course underscore ID. And by virtue of that, you know that this is where course ID is here. So do you want to give it another shot? List me all the programs in Cosi 105. Sorry. List me all the students in Cosi 105.
You would want to figure out what key in the course list corresponds to 105?
Exactly. So I would search here and find this. Now what would I do?
And then you would look in the relational table?
Yeah, these are all relational tables, but this is the table that's creating the relationship, let's say. But okay, so I find 1. Which of these 2 columns would I search in? Because I have a 1 here and I have a 1 here.
The second one?
The one that says course. Because this course is the foreign key corresponding to this key. I would look here and look at this. I find boom, boom, boom. 3 times the number 1 occurs. Tells me there's 3 students in this course. If I want to know their names, what do I do next? Staying with you. I feel like a talk show host. Staying with you. Yeah.
You would follow the keys for the students and figure out the student name
exactly.
based on the key?
Exactly. Clarification, anybody? Okay, what if I want to know all the courses that Nick is taking? What do I do? Somebody else. Walk me through it. Yes?
Look in the student column for all the twos or returns.
I'm looking for all the courses that Nick is taking.
Yeah, so the student column.
Yeah, what do I look? Where would I look here?
Student column of the third table.
This table?
No.
This is the first, this is the second, this is the third.
Okay, the second one, that's what I meant.
Okay, so I'm looking for Nick. I'm looking here, I don't see Nick.
No, so go in the student column in that table.
The student column has 1, 1, 2, 3 here. There's no names here.
No, that's why I said go look for twos.
Oh, go look for 2. How did you know it was 2? You did something first.
Okay.
Look, you got the right answer.
Yeah.
Look in the student table for the name Nick. You find that his number is 2. Now you go to the relation table, you look for the 2s. You find that he's taking just 1 course, number 1. What's the name of the course? Take this 1, stick it in here, it's 105. Yeah?
Couldn't you just join the tables and then look for Nick?
I'm not there yet. This is the gradual unfolding. Okay? This guy's taking the advanced database course. Sure. Okay. By the way, it's 20 past 6. For those of you who could not stay later, I hope, you need to go. Go ahead, no problem. Okay. So, it turns out that when you do your database design and you realize that there's a many-to-many relationship and you create this extra table here, that there's almost always a useful name to give it. You don't have to call it the join table or the relation table. If you think about your problem space, you could come up with a name that kind of makes as much sense as the name courses makes there and the name students makes there. Who wants to take a stab at what a good name for this table would be, other than you because you get it already? Who wants to give a stab at what a good name for this table would be? Yes?
Students taking courses.
Yes, students taking courses. Yep. What was your idea?
Enrolled in.
Enrolled in. Yep. Exactly. Okay, makes sense? Yes?
The computer's about to die.
Why? It's plugged in. What's the story? Is this outlet not doing anything? That's funny.
Oh, now it's plugged.
Oh, okay. I stepped on it. Thank you. And what's your question? No. No question. Goodbye. Okay, so there's almost always, in fact I would say always, there's a name that you can give this table that makes sense. Okay? And you'll know you're doing a decent job at database modeling if you can come up with a reasonable name. The other thing that almost always happens is even though you built this table for a small job, which is to define the many-to-many relationship, you'll find that there's other information that actually belongs there with it. So, take a guess, anybody. What other information would belong in this table with it? Yes?
Just guessing, but if there's multiple sections for one course,
Yeah?
you would want to have, you don't want another whole table for different sections
Yeah,
as well.
yeah.
So you want to represent a course with multiple sections in this table as another
So you have a column here?
column that
Section.
says which section.
Yeah, but you're going a little bit fancier. There's something more direct that I wanted to try to get you to think about.
An ID?
Pardon?
An ID, sort of.
The what?
Because you have like keys for every row, which represents.
What would the ID be? Like a number or what?
Yeah.
Yeah. So this is every instance of a student taking a course. Student A taking course B. What do we know that every student's taking course? What are the facts do we need to know at the end of the semester? Yes, you.
Great.
Yeah! Great! Great. Now, if you look at an actual latte, this is like way oversimplified. In reality, latte has hundreds of tables, okay? But the concept is the same. Once you decide you have a many-to-many table, and we're going to do a fun exercise soon, where we're going to play with that, then you can come up with a semantically meaningful name, like courses taken, enrollments, courses people take, whatever. And often, if not always, you'll find other information that actually belongs in this table. Okay? Okay. I'm going to skip over that. And, oh, it's not even here. Oh, yeah, here it is. All right, guys. Yeah, you're waiting for the fun. Here's what we're going to do now. I want you to design, get a piece of paper out. Everybody get a piece of paper out. I want you to design the data model for iTunes. Everybody knows iTunes, right? Even you Android guys know iTunes. So take a few minutes and design the data model for iTunes. Okay. No? Oh, okay. I want to see everybody writing or thinking. Either one.
Is it with another person?
If you have any clarification questions you want to ask while you're writing, please feel free.
I mean, you want us to like go crazy or just like?
Just where you feel like you're done. Where do you feel like you're done? When you say go crazy, I got distracted what I was doing there. Okay, so here's what I want you to do next. You and the person sitting next to you talk to each other and come up to the board, grab a pen and draw your joint solution on the whiteboard. Okay? Pretty clear?
Hang on, work together. What? Did you go crazy? I didn't have enough time to write, but I envisioned it, yes. Oh, cool. Thank you. Oh, no, that was the song. Yeah.
Did you just do what I thought? Did you just do what I think you did?
Oh, like the iTunes App Store?
I could go all the way to the left.
Okay, yeah, we're gonna have the weirdest one, so.
Alright, so I assumed, artist, right? Song, what? Song? Yeah, of course. So artist, artist that has okay, should I make, I just do this because, yeah, okay, let's see here.
Yeah, song, that in the box. Not song, you got an ID.
Oh, right. I forgot. Yeah, I do remember. And the diamond. Yeah, I love the diamond.
You've got a title.
And that's a
You got a price. What's the diamond of the song? Is that
Oh yeah, iTunes
song
Music.
live?
Yep, song performed. So many 2 in 1. Yep.
Right.
So I want to see entities with properties.
Yep.
Okay.
Got 'em.
Artist.
Oh, you didn't find it? Double search. Just name. I just had name for artist. Do you have anything more?
Name, bio.
Bio. Alright.
The relations are going to be the trickier part than all the different properties. So be superficial with the properties.
Oh yeah, this relationship needs to have.
Why don't you just forget these diamonds? Put one to many or many to many.
Yeah. This is
No.
This is many.
Don't do that. Do this for many, one, and this for the other way, or double for that. I don't want to have to explain diamonds. People are going to be confused.
Okay.
Easy.
Okay?
Yeah, can we move this over here?
Sure. Yeah. I didn't realize. We can use this space for producer.
Come on.
I don't want to. Yeah, because we need like Sony and stuff like that. Oh, label is kind of
That's a lot of work.
The artist is song, not the artist to album. Because the artist never produces song.
Here, help yourself.
Single, just an album that consists of one song.
Remember, if you do many to many, I want to see the intermediate table, right?
Yep.
We'll have one many.
That's one table.
I don't know what you do. We have a user.
Yeah.
And if we have to fill it out.
That's kind of like more artistic.
Most other people.
Well, one artist can have multiple
I decided
labels.
to-
One label.
You sneak on marker? Oh, sorry.
Yeah,
Yeah.
yeah, I wasn't thinking of labels.
Thank you.
Artists. Bio.
Come on, everyone to board! Everybody to board!
What would user be? Is this like
Or it's like iTunes.
Excuse me.
Oh, sorry. In addition to that.
Oh wow, what's the next? Should I pick up that charger?
Yeah, don't step on it, push it under the table or something.
Okay.
Yeah, thank you. Here's one more.
I design over here in our own little yeah. Label. Label is many to many with artists.
Focus more on the relationship in every single attribute, and don't put many to many, put the intermediate table.
Forgot what I brought. So we can select ownership. So like purchase on. Wait, but this why is this a weekend? Like basics.
Because ownership is
You gonna get a partner?
It's not a problem now.
Okay.
But it is a classic case study. It's just like, I mean, there's nothing many users can do. That's wrong. I forgot what it is. I forgot what it was.
Keep it simple. That notation is not like God-given. There's 100 different notations.
The Mitch Cherniak God given.
I know. Yeah.
Mitch Cherniak does not deviate on notation. I think we're good.
I've actually literally never seen that notation myself. But I
No, I haven't. I just forgot one. Yeah, the great thing about standards, right?
There's so many to stick from. Yeah, exactly.
Well, this is good enough. Let's create a new standard and everyone cares.
Yes.
Alright, let's
We were talking about,
there was
okay,
something
we
else.
have songs
Let's put like.
and artists and albums, like, do we want to have it
Oh,
similar to
reviews.
the
Oh, it's
middle of the
perfect.
future?
Yeah.
Relating to the
No, no, no.
keys?
Yeah, but
Then we're thinking,
we're done.
the thing is, if we have a songs table,
No,
artists and
right. I don't think we need to.
Artists and albums.
does the song always have exactly one album?
Don't you need a table here?
Okay, well then you don't need it for that because it's one many.
No.
One album has many songs.
Yeah.
No song
One
ever.
many artists can have.
And one artist
Artists
has
have many songs. So we don't need, do we need this? It's all on this table, the songs table. And
songs by art. An artist. Every song is done by one artist. Well, unless you want to take care of the cases where two people are singing together.
But I feel like that's just the artist's name is going to be
Okay, that's fine. I mean, these are. I know these. I'm familiar with this practice. There's a lot of things you have to decide.
Okay, so we were just
Make your decision. If you're a new product, you design your new.
I have an idea of the many meanings.
When does it come up?
Like when a song is done by multiple artists.
What genre?
Genre.
Yeah, one song will have many genres, and one genre will have many. That's what I.
Right. Yeah. Should we start from there, or should we do the basic?
Do whatever. I mean, this is what you're doing the right stuff. You got to think about these debates. Should they be called songs or should they be tracks? What about an instrument? What about genre? Where does it fit? You just struggle with that stuff. It's not. There's a lot of decisions you have to make. What?
We're taking the diamonds away. We're making it like semi-diamonds just so they wouldn't be tabled.
Stop showing how clever you are and actually solve it.
Okay, we're done.
That's it?
Well, no, we need another one here because it's many to one.
Okay, so these are all the colors, the ID. So we just have, we don't
Album.
want to.
Yeah.
An album has many artists?
An album can have multiple.
Yes, so album.
Yeah, I did, but an album can have multiple artists.
But
I don't care.
We don't have artists because.
We're good. Alright, now let's just draw the Lady Gaga
Wait. What about genres?
Genre?
Yeah, don't be lazy. Come on, guys.
It would be just many entries.
I want you to do. No, I don't want you to be fancy. I want you to be more comprehensive. Don't take the easy way out.
Nope, song can be
like.
Yes.
Okay,
The name of the album, and then
I didn't know you to be shortcut, easy way out.
That's
guy.
you never met.
Oh, not shot. What is this double line? Never shot.
It's a compound, so it's something like you have.
We don't have that. We have.
We just want to join itself. Although a genre would technically be.
and I mean
Look at this mess. Look at this mess.
These guys, you know, they're Yes.
So it could be.
That'll work. Oh yeah, even.
I was disappointed on your theory. Did I lose bad points? You kind of did, actually. Yeah, you made one serious mistake.
Wait, look at what happened here. Yeah,
Straight up
here.
did it wrong.
Then-
It wasn't like, oh, the arrow
Look at what
was like wrong. No, it was just like, this is just not a
Which
solution.
one?
The one
No,
with
it could be more.
where it was like
You could have like this
ones
one
or
has
an even number of
no.
zeros.
You cannot put it here because it's both.
Like,
It's like multiple
100%
genres.
wrong.
Did I get 100% off?
No, I think you got like 1 point.
In that case,
1 point off?
you could have the
Oh, 1
song.
point.
You got
Let's say
1 point.
We had 1, 2, 3, 4, 5 songs, so you could have the name. So
The
you
one
could have,
or an even
Okay,
number of
guys,
zeros.
was that let's focus on this instead.
No, we're trying to sabotage them so that
So
ours
one-
looks
Oh, no.
genre
Wait,
two,
why is it?
Song 1 and
Oh,
genre 1 as well.
yeah.
Song 2 and genre 1.
It's more like an object design than a relational database design. Really.
What else can we go
You want to
on?
just write the tables?
Yeah, I want you to do a relational database design, not an object
Should we
design.
do like artists?
That's data modeling. We're not talking about class
That's,
structure.
they're the same. This is isomorphic. Okay, we'll write the table.
Name,
Alright, songs.
album.
Ooh, it's got an ID.
It's one artist
It's got
many.
a title.
Yeah, I think we
Yeah.
should do album.
It's got
Oh, we actually do. Okay.
What else does it have?
That was the
Like,
assignment.
Date of birth, like stuff like
I thought
it's
I
like.
thought they were in the same.
They
I don't know.
don't, I
They
didn't
don't
track
put
that.
it.
No.
Oh, yeah. And that's why I like my notation of
Okay,
artists.
and then, what else? Like ID.
Sure.
Yeah,
The owner of.
yeah. That deal where you get the PR diagram.
We're not, this is not an ER database, it's a relational database. Where are your relations? Where are your attributes?
ID, title, parentheses, users, you've got ID.
So, I don't know.
Say playlist.
If it's not prior,
Table.
extra stuff you have to go. I just need to check
What would be the relation for playlist and songs? So a lot of songs can go but no, many songs can be in many
Or did you
playlists.
just kind of take it for granted?
So the same song can be in
No,
a
there's
lot of
actually a very
playlists.
precise graph tracer.
So that's why you would need a like a relational.
Computer had to turn this
Well,
in.
let's say song number 1 is in playlist 1, 2, 3.
Wait, so you're on label and
Yes, you have a different one for playlist. Also, call it.
There we go.
Yeah, then we have a combined
iTunes client. We assume
songs
Which
and
one did you
playlists.
mean?
It's the same thing. I want a data model for the music part of iTunes.
So oh yeah, they like my iTunes or like the store.
Yeah, the
It's
iTunes
the same thing, right? You have, you
But in this, you don't have playlists in the store.
okay, so put playlists in. Go ahead.
Yes.
Yes. Oh, I guess they could be
No.
public
Find
playlists.
every song where the
Well, now we have to
where
keep
the
both
song
of them
name
all
is.
updated. So playlists can just include songs.
Let's not add. Let's finish this and then change more titles.
What year
What did we have? We had courses and what students are in, right?
Wait, we're not even.
No, this is a list of the playlists. You don't have a bunch of songs. You have only the names of the playlists. See what I mean? Right?
Oh no, that's the
The
problem.
playlist.
Because playlists on the iTunes
That
store have
extra thing is this thing. What you see here.
Why don't we just get rid of it?
It's not a one-to-one.
Because you want to make
Let's
the
assume that they
playlist
just
has
copy it
also
over.
labels, number,
Alright, the song has album ID, there's an ownership table. What happened?
date of people, like rating. You see, like rating for the
Probably
oh wait,
not.
like users, or user created. And then there's we created. So we have song and playlist. So we can have song 1, 1, 1 is on playlist 1, song 2, 2, playlist 1. See, so that relates.
Playlist just relates songs to playlists.
Anything else?
I'm not.
You're not sure about it. Because every playlist has its own attributes, like
I understand why songs.
just like an artist doesn't have all of his songs, it has a different table where there's like song artist type of thing.
Artist spells album.
Maybe also that's the so artist has all the attributes that an artist has, and then it has a relational one with albums that has album 1, 2, and 3 are all.
I don't know how it works.
The whole reason is because you don't want to create multiple.
User
Let's
finds a
ask
song.
Peter.
We have a user with
Yes.
an email. We got a user in the song ID for the song.
I would say
Songs in a genre.
So I would both things. Have a playlist that has a name and a lot of songs. There's name, song, name, song, name, song.
Genre is just a list of genre names.
Then we decided that it could be a playlist.
Compared to the course that students.
No, you're right.
I think it
With the ID number,
Yeah.
an ID of
No one
the
would ever
song.
model it like that. They'd have to throw it in a small table. It'd be easier to enumerate the type.
Well, yeah, because,
Because I was thinking that a playlist has its own attributes. I'm saying playlist, the table of playlist has a bunch of playlists. The playlists have a name, have a duration, have a number of songs. And then we have a relational, like a combined one, where we have song number 1 and 1 is in these playlists.
you're right. Because you can now have other information other than the playlist traffic, you can have other data about the playlist.
Like who created the playlist, how many songs is in it, when it was created, the year.
But it doesn't make sense that we
That's
should
still doing
songs
people
here
about all
and
songs.
just
Have to get wrong.
But you can look up all the song 1 and 10. You can still look it up that way.
Well, the other principle that happens here is if you put the name in here, then if I have 100 songs in that playlist, yeah.
Okay.
Then if I have 100 songs in the playlist, I have the name is going to be, the name of the playlist is going to put 100 times.
Yeah.
And that's redundant, you don't want, you
But
don't,
want to go on the playlist?
no, because the
Number 1 go
playlist,
here.
it's number 1, but none of the properties of the playlist, not the name.
Just the ID.
Just the ID, exactly.
So that's better.
Yeah.
What else?
Okay, I didn't understand that. I thought it was like either 100 rows here or 100 rows
Yeah, no, I didn't make explain that one of the big
credit card
the design is not having any redundancy.
Executive multiple credit card.
When you open something that's a database is corrupt, it's something like
Get all the
this. Like some of the playlists have one name and it's a different name.
Oh, I do. I gotta go grab my database.
I can explain.
Okay, okay, guys.
Which one do you
Yeah,
use?
let's wrap.
Oh, you didn't like the one you did, right?
No. Yeah.
But that's redundant, right?
Yes.
If they're both redundant for this one.
Oh, it's almost done.
They're not, no, this one's not related.
Now that's better.
True, because
We
it's
used
related
a lot of
to the
space.
Right.
Everyone used the board, I
This one
think.
has 100
Oh, no, not
Right.
true.
So is that what you wanted?
But that's the information you wanna get from